So thanks everybody for being here. I really appreciate the opportunity. One of the most fun parts about being involved in analytics for the past 5 years is actually getting out and talking to people about what we can now do with data. So let's let that be our point of beginning. You know, data, it's everywhere. We're hearing about it constantly. But what does it mean to building owners, really? Owners and operators, right? And I'm going to start with a pretty bold point about that. Data is a new form of money. It's being used across all kinds of industries to generate financial return. And it shouldn't be any different for our buildings. But we have to understand what do we mean by the data and what's involved to utilize it to generate financial return. And the concept is actually quite simple to describe. We can create value if we can detect patterns in our data. Patterns that represent faults with our equipment, or maybe just deviations from expected behavior from following design planned operation of a facility. They could be anomalies. Kind of a fault is something, oh, I know that's broken. Anomalies could be, what is that? What is that bizarre behavior that's going on, right? But all of them represent an opportunity for savings and improved performance of our building. But we have to be able to deal with the data to detect those patterns. But that's what we're talking about, detecting patterns in data, patterns that are worth something. And when we talk about utilizing data with buildings, it starts with a very simple question. Do we know how our building systems are operating? Sounds like a simple question we should be able to answer, right? But it isn't that simple anymore. Buildings are increasingly complex. And we have a number of reasons that we care about it answering that question, right? We're all here, we're seeing lots of new technology, we're witnessing changes in government regulations, sustainability mandates, but there are a number of reasons we care about our buildings running properly, right? It may just be money. A better running building will cost less. We'll have a higher asset value. That's one of the most interesting things we're seeing now is things we all believed are being validated by independent sources, like, if you actually have a more efficient building, it has a higher asset value. And in fact, the increase in asset value could dwarf the savings in energy. Okay, we all been running around trying to save a kilowatt. What if we increase the asset value by millions of dollars, right? Regulatory requirements. Cities, I believe Toronto is one of them, require buildings of a certain size to report their energy. In other words, at least meter that data. And of course, make more money. And finally, the softer one, but one that is coming on, I think, with increasing steam, is meet societal demands. There is an expectation that we're going to be better stewards of planet Earth, energy, our buildings, etc. And that is increasingly taking hold. So that's why we care. So let's go back to answering that question. If you said to me, yes, I know how my building's operating, then I might challenge you and say, really? Who is it that is verifying that they're doing the right thing every day? Would that be you? Who is it that verified that those control strategies, by the time they made it from specification to implementation with value engineering, are actually well designed for the equipment system? Who's that person? Raise your hand.
Every control guy in here.
Okay, there you go. There's plenty of them, right? That the assumptions they were based on were correct and remain correct with changes in building use, design, etc. That the equipment and sensors haven't degraded, right? They're all running as perfect as the day we unwrapped them out of the box. And one of the biggest problems, that they have not been interfered with by carbon-based life forms. Okay. So who is going to answer all of those for me in the affirmative? And the reality is, you can't. It's an impossibility. There's too much data, if we even had it all in front of us. The systems are too complex. Nobody knows it all. There aren't enough people, and last I checked, they're not going to let us hire them. Okay, so what do we do about it? So analytics technology is a solution for this problem. And basically, again, it's that simple. Let's look for issues in the data. Look at the data, let the data tell us things, but of course we need tools to do that. Things like equipment faults, deviations, trends, right? people like to think, well, if it was broken, I'd know. Not necessarily. I'll give you a good example of that. Let's say we could detect loss of delta T across a coil. Okay, so we expect 8 degrees, we're only getting 4 degrees. But it's a shoulder season day, it's a mild day. We're not going to have any problem maintaining the space. But what happens when the severe day hits? That's the type of example that's really predictive. Right? Can't tell you what day you're going to be unable to maintain comfort, but it's coming pretty close. Okay? That's not going to be picked up by other technologies, control systems, etc. But it's really important. Okay? One of the other unique things about applying technology to the data is that it's very much unlike other energy efficiency measures. And this is a double-edged sword because it's unlike it in some really beneficial ways and unlike it in some challenging ways, right? But you typically, if you have a relatively modern system, building systems, you have data there. And just because it's not already ending up on your desk every day doesn't mean you can't get a hold of it, right? You typically don't need a ladder. You don't need conduit. You don't need a tool belt. But you do have to find out how I can connect to the data that's out there. Okay? And a lot of value can be drawn from historical data. There's a big focus on real-time. Everybody wants real-time, et cetera, and that's great. And we'll talk more about that. But you can get tremendous value out of historical data, and we'll present some examples. So we say it's relatively easy. Nothing's easy in buildings, but it's relatively easy to add to what we have if we have a relatively modern building. So I want to step back for a moment away from buildings and valves and dampers and equipment systems and make this point. Analytics is changing our entire world. As we sit here, we are the subjects of analytics. They know where we are on our phone, what we looked at. There's internet tracking for marketing and sales, right? If you look, if you do a search because you want to buy a new skill saw, then for the next 3 months you're going to get ads for skill saws, right? They're tracking, they're using analytics to do all that. There's a reason that when you go to a convenience store, the diapers and the beer are really close together. Right? Somebody figured that out. Right? Okay. And these are just some examples from the news, right? Whether it be building better customer relationships, creating more profitability, fighting crime, and selling us stuff. It's changing our world. So I like to say, data isn't a fad. Data isn't going to go away. We're not going to be sitting back in 5 years and go, oh, remember when we were all worrying about data? That was funny, It's not going away. It's coming on actually like a tidal wave. So we have to learn how we can use it to change our buildings. So how do we do that? Let's start at a high level, a conceptual level, right? We want to get as real as we can about what's involved here, challenges included. So the first step is, what data do you have? Ask that question, identify it. What data do you have? Where is that data located? How would I connect to that data? And remember, connect might be, I'll give it to you on a thumb drive. That's a connection that gives me data. Okay? Or it might be a live connection to a building automation system. If you have that ability, that's a great source of data, but one of the key things we like to point out about analytics, you don't have to have a live connection to a BAS system to be able to get useful data and apply analytics for value. There's a whole other category of data that's often overlooked if we just think about the sensors and valves in a building. And that's what we call facility or asset data. For example, the address of a building. When's the last time you entered the address of a building into a control sequence? Probably never, unless somebody wants to try and prove me wrong. But probably never, right? But that's useful information. Why would I want that for analytics? Well, with the address, I could look up the correct weather station and get the weather conditions because that weather's out there. Okay, that'd be another reason. How about the size of the building in square feet or square meters? Because now I can normalize the energy and actually look at performance, not how many kW and kWh, but I can look at per square foot and compare against industry benchmarks. Square footage doesn't end up in many control sequences either. But it goes beyond that. Interesting thing, it might go to the brand of equipment. If maybe I have a multi-site retail environment and I use brand A here and brand B here and brand C here. How would I like to know that and do comparisons between them? Because I might see different energy costs, I might see different repair costs. How about repair activity data? That doesn't end up in a control sequence. Well, that may be available to you, and it can give you better ability to detect correlations and patterns and relate to things, okay? Type of construction, and we tried this model of construction here, and now we switched to this type of HVAC or building design here. Let's do comparisons on that. That's a piece of information. So facility data is a huge valuable source of information to use for analytics. It's often overlooked when we just think about sensors. Next one's pretty obvious, right? Utility data, whether it's electrical energy or water or gas or outflows, etc. Keeping track of that, and that, again, though, that brings up the where question. You might have utility data coming in from a smart meter from the utility company. You might download it in an XML file from the utility company. It might be a live feed, or it might be years of data in an Excel spreadsheet. All of that is valuable data. Different things you can get from it, different ways you bring it in, but it's all valuable. Weather data we mentioned. With Weather Service, you can get the weather data, including forecast data, so that you can use it with your analytics to identify patterns, relationships, etc. And then the other one is production data. When I put this up there, people think, oh, a factory, how many widgets you produced, right? That's fine if I was doing a factory, but this building has production data. Every building has production data. For a hospital, it might be the number of beds that are full. For a commercial office building, it might be the amount of square footage that is leased, or it might actually be active real-time occupancy data, right? And for a restaurant chain, think about a restaurant chain. That might be revenue per site, because busier the restaurant, the more energy that gets used. It's just natural. So if I want to penalize Jerry for having a high energy bill, what if he has the most productive franchise operation? He's got a line out the door all the time. I don't know what he's doing over there. He's using a lot of energy, though. Right? So you have to bring all of these things in and think about it that way. So identify sources of data that's available to you and how you're going to connect. Live, batch, thumb drive, SneakerNet, whatever. So the next step, though, is that all that data has to be brought together. It has to be brought together in a database of some type. And one of the things I've just described is we have all this dissimilar data out there. All different types, and guess what? It's not in the same format. Maybe all the BAS systems conform to BACnet, but well, look at all this other data. Excel spreadsheets, XML feed, who knows what all these are. So you have this new challenge of what's called normalizing the data, but now you're going beyond the control system. So you have to bring it together, and you have to bring it together in a way that makes it uniform. And that's been one of the big advances in the past number of years, is techniques to do that. And one of the main ways of doing that is a new open source standard called Project Haystack, which is a worldwide group of people who came together and said, let's come up with standardized approaches to describing our data and our systems. And we do it with tags. So we would tag a piece of equipment to describe what it is. Okay? And that's a key part of onboarding this data and making it useful. And it's a place where engineering effort and money goes. It does take time and cost to do that. How much, it varies. Let me give you a quick example. Let's say you say to me, hey, John, that sounds really interesting. Okay, smart guy, go analyze this. And so you point me to something in your system, and I look at it, and it's got this 12-character cryptic name. I got no idea what you meant by it. And the last value it had was 76.2. Forgive me, I'm from a third world nation that doesn't use the metric system. 76.2 degrees Fahrenheit, right? And you asked me to analyze it. Right? I look at 76.2. What is it? Is it room temperature? Because if it is, I'm getting a little warm. But if it's a return air, it's like right on the money. If it's a chill water supply temperature in August, not so good. So we need to know what it is. So you might tell me, oh yeah, John, that's degrees Fahrenheit. It gives me a range, but that's a room air temperature. 76.2 seems a little warm, but wait, Jerry, what's the schedule? Because you know what? At 3 a.m., that's fine. 9 a.m., not good. So what we're talking about is things we kind of take for granted if we're involved in deploying and managing these systems, but how do we make the data represent that? And the way we do it is with a thing called tags, and this industry consortium that's come together to define standardized tags. So we'll tag our data to describe it, to say degrees Fahrenheit or C, space temperature sensor, discharge air temperature sensor, chilled water supply temperature sensor, kWh meter, etc. But anyways, that's an important step, and that's part of what we want to do today is talk about some of the real-world challenges, not just how wonderful this stuff is. But okay, so we get it in a database. Now it's there in a way that all this, it's called multi-structured, semi-structured data, can work together. Great. Now the analytics portion can take over. An engine processes rules or algorithms. You can call them what you want, right? If you want to sound more intelligent, you put on the glasses and say they're algorithms. However you want to refer to them, right? They're looking for patterns in data, patterns that relate to something, right? Something important. And we'll show some examples. And those, when they're detected, you get results. And then the key question is, well, what do we do with the results? How do we drive what I call the workflow process? Okay. But before we go there, let's just, what are we talking about? What types of issues? And these are just some to kind of get us all on the same page, right? Simultaneous heating and cooling. It happens, right? In fact, I'm pretty comfortable up here. You guys comfortable? Anybody willing to bet their life that it isn't because we're simultaneously heating and cooling? Could be, right? Short cycling. Lack of diversity control. If you're trying to do demand management, you try to do diversity control to make sure not all your equipment slams on at the same time, and people write control sequences to do it, and it sounds simple, but it's actually pretty tricky, and are they working? Then there's a lot of stuff you can just do with energy, right? Detecting deviation trends, deviation of energy intensity metrics, whatever you might want here, kW per square foot or square meter per day, comparing against benchmarks from the industry, comparing it against past baselines, but then going to the next step, and this is the key point about analytics, right? We could all get out Excel and chart and graph the energy and look at it and go, aha, I see something, but nobody has time for that. Well, the key advantage of algorithms is there's this machine, this engine doing it, and it tells you, it says, hey, you went outside of the range at this time for this long, by this much. It happened this many times, and oh, by the way, here's what it cost you based on your tariff rate. And delivers you that information. Think about how more actionable that is than say, oh, I got some raw energy data, I'm going to spend the rest of the day trying to put it into Excel. And that's what we're really doing to make data useful, make analytics drive improvement. We talked about degradation of performance, like with the cooling coil losing delta T. Economizers open when heating and cooling. A number of the U.S. government labs, some of them are focused on energy and stuff. And I'm paraphrasing a bit, but economizers were supposed to be one of the great energy-saving tools. And it turns out they may be the worst energy-wasting tool because if they don't run right, they do a really bad job, sucking in hot, humid air on a hot summer day instead of closing off. And the reasons for that can be a bad control sequence. It can be a bad sensor, right? It could be a broken linkage, or one of the ones that was found on one of the projects we did was a new type of problem known as dead crow. Dead crow in louver, prevent louver from closing. It's a real finding. It was up there who knows how long, Well, it still had feathers, so it was probably not that long. But who would have known, right? Expensive bird, okay? Non-functioning sensors. This one's pretty interesting because it's a kind of a standard and you think simple rule. We talk to people when we do projects, when our partners do projects. We say, well, one of the rules we run around is check all your sensors. And they go, my sense isn't working. If it didn't work, I'd know about it. And I say, yeah, I know. Jerry, just humor me. Let me turn the rule on so my boss will get off my back. And people get astonished at the findings with sensors. And I'm going to show you one of them. And I'll show you how simple, but how complicated the problem is. And then, another simple one, lights and other loads operating when they shouldn't. And you'd say, well, that's not a complicated thing. I don't need technology to solve that. But I'll give you an example. I have 925 retail sites with managers who are constantly turning over. And, the sale starts Monday and it's Sunday night. And what do? They turn on every light and then they're tired and they go home and the lights are overridden. And when did that happen? I don't know. Last summer. It happens. Who's watching for it, right? These are the other things we see, is different buildings have different operating characteristics. And I think that's one of the big trends in analytics is, the rule I might have for building A would not be appropriate for building B because the chiller plant is completely designed different. And what we're seeing has taken hold is programmable analytics. Just like a building automation system has to be programmable beyond the standard sequences it comes with, analytics needs to be programmable too, because buildings are different, designs are different. And if we're really going to identify issues and not get more wasted alerts, we have to be able to adapt those rules. So we need to be able to tell. All right, so here's a bad sensor, real-world example, okay? First, I'll ask you, how much does a pitot tube sensor cost? Somebody said there's contractors. Come on, guys. Somebody give me a number. A pitot tube sensor on a variable air volume fan. $150. Okay, anybody else? Yeah, close enough. Wrong. $3,000.
Well, can I sell that?
Right. You're close. What you're supposed to say is, what the heck kind of sensor are you selling me? Is it platinum? You know what kind it is? You know what kind it is? Broken. Simple, dirty sensor. You know what it read? Low pressure. Run that fan. Full speed ahead. Today, tomorrow, the next day, and the next day, and the next day, and the next day. Comfort? No problem. Everything's fine. Alarms? Mm-mm. Complaints? No way. Okay? 15-minute of service if you knew that it was occurring. And it's actually a pattern that analytics can detect easily. Human beings could detect, no question. If you had the time on your hands, you could go find this stuff. It just doesn't happen. Real-world example, okay? And here's the pictures of, the software detecting these issues and how much it was, the reduction between the red and the blue. That's money, okay, that was saved because the fans didn't need to be running at 100%. 13,000 kWh, it was $1,300, sorry. Okay. Of course, that was just in the first year, so if we expect that sensor to last a few years, it was worth at least $3,000 or $4,000. Okay? So, a real-world case of how analytics saves money when there was no alarm. We'll talk more about alarms in a moment. Okay, so, this is all wonderful. But people say, well, I've got a lot of things. Just go out on the floor out there, right? There's a lot of people promising that they can save me a lot of money and energy with different products. So you need to ask, and building owners and contractors ask, where do analytics fit in the whole picture here? So we want to compare them to some of the other technologies out there just to show the difference. All these are useful technologies. That's not the point of good and bad. It's where do they fit, okay? And so we found there's try to categorize them helps, right? And we're going to focus just on data-oriented options or tools out there, right? We have alarms. We've had alarms for a long time. We've had our fill of alarms, right? We have analysis tools. There are very sophisticated analysis tools that a knowledgeable person can sit down in front of and work with. We have fault detection and diagnostics. The term is often combined with analytics. They're actually different. I would call fault detection a subcategory of analytics. Not a negative, just it's a subcategory, because analytics are doing even more than that. And then, there's this whole thing, we need to have this data. So let's look at some of these. So analytics versus alarms, and this example was given to me, and I thought it was a great example, okay? An alarm is when you're on the gurney in the ER and they're getting ready to stick a tube in you someplace, okay? Analytics are the lab test you take every year to say, hey, cholesterol's getting a little up there, you ought to watch what you're eating. Which would you rather have, the tube or the report? I'd rather get that lab test and consultation myself, okay? So that's one difference. When it's an alarm, it's kind of late. But here's one of the most important other things about alarms. And it's kind of subtle, but an alarm, those of you who've worked with control systems, means that you understood the issue at the time you were implementing the system so you could know to program it. I know this might happen, so I will write an alarm for it. The temperature might go above 76 degrees or 78 Fahrenheit. Okay? But analytics finds patterns in the data you didn't expect. I never expected that the pitot tube would be telling me, low pressure for continuous periods of time. I didn't think to write an alarm on that. It might have been kind of challenging to do it because is that right or wrong? We're looking for patterns in data. So they're finding things you couldn't have foreseen, or it would be very difficult to foresee a lot of the things that come up with analytics. So that's a fundamental difference. Did I know ahead of time? So there's nothing wrong with analytics, but they're just limited because, you know, what do? You configure a point, you put the basic alarms on it, move on, next one. Okay. The other thing is, you know, alarms operate in a controller out there, so that means they've got the data they're aware of. They can inputs and outputs, maybe a few shared variables, but that's all they have. Whereas analytics can combine information from outside of that. The energy cost versus consumption. You know, the meter's got the consumption, but the cost is coming down from the utility. Okay? So it can combine a wider range of data to identify those correlations and patterns, something you can't do at the controller level. There are things you can do at a controller level, no question, but being able to combine all these different sources of data together is different, right? You know, again, based on weather, vendor, materials, construction design, etc. So that's a little bit of a difference. You know, I look at an alarm as it's compared to, it's also the time it occurs in. An alarm means you went below the limit now. It doesn't say, hey, stupid, you've been heading that way for the past 3 days, but you didn't notice, so now it's a crisis, right? So that's another key difference. Alarms trigger, trends identify, okay? Patterns emerge in the data. Okay? And typically alarms require touching that end device, going back into that control system and messing with it, reprogramming them, adding them or whatever, which comes with some type of cost, some type of friction, some type of challenge, right? To go back into an existing system and reset up alarms or modify them or say, well, wait a minute, I could have written an alarm for that if I had ever thought about that 2 years ago. Okay? Not having to go in and modify end devices is essential, especially if you're a service company. You may not be able to go in and modify the control system in any way because you know what happens. You'll end up owning everything that goes wrong in the building from then to eternity. And then, of course, we all know about cascading alarms, right? One little thing happens, but you get 20 different alarms. They're all related to that one root cause, but you just get cascading alarms, otherwise known in turn the printer off. All right, so let's talk about analysis tools. A lot of valuable analysis tools. They have a really important place in the market. They're essential, but there are some things about them that limit their effectiveness for the type of thing we're talking about. You know, the first is they require an experienced user, right? Typically, if we're talking energy analysis tools, you get somebody who's an energy engineer and they know how to, you know, run those tools and slice and dice and do all that stuff, and that's great, and they come up with fantastic things. But you know what? How many people can engage in that? And even sizable organizations just can't have enough of those guys to deal with all the data. So they can do it, they can't do enough of it or enough of it cost effectively. Okay? So the human becomes an essential part of the analysis. Jerry's not in today, I get no report. Analytics is similar in many ways, but it's automatically crunching through. We like to say that if you would have known what to look for, tell the analytics system to look for it. Make it a rule. And now it looks for it and says, hey, I found that. Okay? The human doesn't need to do the analysis. The human now only needs to respond to the result. I found that pattern you asked me to look for. Okay? But again, this other thing, really, it's kind of intangible in many ways, but identifying things you couldn't have even looked for based on your knowledge, because as I think a lot of people know in the room, a lot of strange things can happen in buildings that nobody would have ever believed could happen, right? So the difference is analytics is constantly processing the data and applying what would have been the knowledge of the operator continuously. And here's an example. With an analysis, I might get a graph of energy use. Pretty typical, right? And if I'm a knowledgeable engineer, look at this peak out here. Wow. Huh. We get another one. I wonder what's causing that. With analytics, pretty similar, but now look what it does. What we have down here is the actual equipment run conditions, the on-off conditions, that is aligned and correlated with the energy data. So what was going on when I hit this peak? I can see which pieces of equipment were running. What was going on when I hit this peak? I can see which piece of equipment are running. a small but absolutely huge step forward into understanding and resolving any issues and figuring out, can I address these peaks? What would I do to address these peaks? It's a pretty simple way to show the difference between analysis tools and analytics. Right? Let's talk about analytics and alarms, right? The typical alarm. A good one. Let's detect when KW goes above a specified target in real time. Great. So I get ding, 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 you're above KW. What's an analytic view of that? An analytic view of that would be, I'm going to identify the periods of time KW is above the specified limit across any time you want to know. You want to know last week, you want to know last month, you want to know the last 3 years. I'm going to show you all that graphically and in a table. And then, by the way, let's calculate the cost impact based on the actual tariff and show the duration, frequency, and cost of the issue. That gives me much more information than, ding, you're above the limit. Okay? And one of the other interesting things about, when we're thinking about control system, we're always thinking about that value on the screen. What it is right now, which is essential to running a building. But what if you have historical data? You want how often, the utility company comes in, is a good scenario, and says, hey, I got a great new rate for you, John. Wow. It's half the price per kWh. I'm going to be a hero with my company. And then he says, well, but it's got a penalty. Oh, at 425 kW. What do I need to evaluate that? I don't need to know whether I'm an alarm for 425 kW now. I need to look back over my historical energy data for the last 2 years and see how often and how long and and by how much. Is it realistic to trim those demand peaks to get on that rate? That's the difference. Somewhat subtle, but a huge, important difference between analytics and alarms. And here's the analytics showing the periods of time. This happens to be over a month, and you can see the thickness of the line is the duration, and we can zoom down and look at it down to the minute, right? Okay, periods of time I was over 400 kW, total duration, periods of time, and the actual cost shown here, and then which meters we were sensing that identified that. That's actionable. I can make a decision or evaluation now about that rate. I have much better information. Okay, so let's look at another real-world example. We were going to actually transition to a live demonstration, but the technology is not cooperating with us today. But fortunately, I had slides on this. This is a real-world example I wanted to show you in a site that I was going to connect to. And this is a screen that shows identification of an issue. So I've circled it with red here, and you can see it's not that long a bar, but I'm looking at a whole month. Right? So it tells me on that day, which is the 19th of March, the outside air damper was stuck open. So one of the key things about analytics is how do we engage the operator, how do we help people resolve issues. So a simple tool is just descriptive information. So when a rule triggers, it also says, hey, here's what was found. The damper should be closed. I was looking for the closed condition, but the temperature differential between the mixed air sensor and the return air sensor is exhibiting a pattern that can't possibly happen unless the damper is open. You may think it's closed. You commanded it closed. The signal says it's closed. It ain't closed. Okay? And it detected that pattern, and it can even go on to recommended actions, right? Number one might be look to see if the control signal is oscillating. Maybe I have a hunting loop. Number two, maybe you look to see if it was commanded open, overridden, because maybe they were painting the space and decided they needed to flush it with fresh air 3 months ago. Number three, get a ladder. Go up on the roof, remove the dead bird, make sure the linkage is working, right? And even a priority. So engaging and providing that information to the operator about, I found this, and here are suggestions about what to do. Okay? So we've identified that. But we're kind of looking at a monthly view. If I clicked, it would take me down to more detail. Okay? So here now we're looking at that specific day, Thursday the 19th of March, and now I can see the patterns much clearer. Okay? And here's my rule, and here's my duration, and here's the time. I think it says 6:32 p.m., and I can see that I had a period of time that condition was true, and then it stopped, the white space, and it came back again. So it happened twice. But what else does this visualization approach make really obvious? Correlation, right? You don't need to know a lot to go, hey, these two things are happening at the same time. What is that? Oh, that happens to be short cycling between heating and cooling on the unit. Aha. Maybe that's the root cause of this problem, right? So you see this, and a big part of analytics and the technology that's being done by companies across the board out there is how do we visualize this to make it quick and easy and understandable for the operator. So it's actually equally important to the magic engine that detects patterns, right? So I can see that, and if I kind of blew it up a little bit, I can see the time of occurrence, I can see the correlation, I can see the duration. I know a lot more about this. Okay, I wasn't just told, hey, Jerry had a problem on the 19th. Okay, I can really see what's going on, so I'd like to know more. And the next click takes me to what we call the full details on an issue. We get the timeline, right? With the crosshairs, so I can see exactly, now I get very refined data on when it happened. But then it goes and it does this interesting thing, which is to automatically collect relevant information. So you might ask yourself, well, how would it know what's relevant? And this has to do with that when we bring the data in, we tag it, it creates information that the software can interpret. Like, well, if the issue happened in a specific site, this happens to be Gaithersburg, Maryland, well, I might as well go get the weather and show you the weather when that problem occurred, because you know what? That might be helpful to you. And the issue was detected on a specific rooftop unit, so hey, what do you think? Maybe I should go and get all of the I/O information from that rooftop unit. I should get the discharge pressure. I should get the discharge temp, the return temp, the zone temp, the set point. I should get the outside air damper control signal, because I'm supposed to look at this, and if I look at it, I can actually show you that's 5% minimum, which is the off position, so I've answered my first two questions. It's not oscillating. It wasn't commanded open. Guess I better get that ladder, right? And down below, it shows us the on-off statuses. And notice it's aligned at all. That's one of the key things. All this dissimilar data, really, gets all aligned and normalized and correlated. So I can see that, at my occupancy, that's this blue line, starts at 9 a.m., goes to 9:15, but my equipment started up at, it happens to be 6 a.m., and the purple line is the fan. And the next line, and look at this, what does the next two lines show me? It shows me that both stages of electric heat started simultaneously. This is a key point about analytics. I did not write a rule to look for that. I did not even think that that could be happening. But it shows me that pattern in the data. And I, as an operator, go, wait a minute. I thought I specified that we're supposed to start one stage of electric heat on an initial call for heating. It's not working that way. It didn't get checked out, commissioned, or found, or maybe it's a seasonal thing, but you know what? We've been hitting demand peaks. What if I have 200 zones and this is happening everywhere with electric reheat? Chasing that down manual? Absolutely possible. Practical? Viable? I would suggest no. Okay? But the point here is we're seeing patterns even though we didn't write a rule to look for it, because this whole idea of converting data into information and patterns for people to consume. Now, if we look at what else happened during the day here, just get familiar with this a little bit. The fan turned on at 6 a.m. and it ran right through to the end of occupancy. Stage 1 ran almost all day. Stage 2 shut down around here. But look at what happened here. Right here around 6:50, 6:45 p.m., Stage 2 shut down, which is exactly when the conditions were detected. And if I look a little closer, I see this, and that red little block shows me that cooling stage 1 turned on for a short period of time. Happens to be about 15 minutes. Here I am in the middle of the heating day. The cooling turned on for 15 minutes. What's with that? And what did it follow it by shortly thereafter? Oh, well, let's just slam on both stages of electric heat again. The point, the temperature in the space could be perfectly fine. No people might be complaining. But the systems are not running right. I may have demand charges, consumption charges, equipment cycling, all of these things, and it visually brought it out to me. That's really what we're talking about with this new generation of analytic tools to bring out to make this data useful to us. So that's an example. Now, you know what? There's other users beside us guys who like equipment systems, and I'm assuming everybody does. But you know, we've been looking at the data from the point of view of an operator. You know, an operator who would understand what damper stuck open means, right? Would understand, ooh, 6:42 p.m. and would see that. But we also know there's other users, and this has been one of, I think, the big area of growth in analytics, is there's other people involved in the management of facilities who don't care that the damper was open at 6:42 p.m. They want to know different things. They want to know things like, what problems am I having in my buildings? Which problems in which buildings? How often do they occur? How long do they last? And of course, what do they cost me? I don't want to know 6:42. I want to know that. So other ways, and again, it gets into this whole visualization thing, other ways to present information. This is a technique called bubble charts, and you can do bar graphs and whatever, but here it's showing me the size of the bubble indicates the magnitude of the problem, right? This happens to be, if I'm worried about cost, it's KW exceeding target that's the biggest cost value. These are all examples of ones that have cost associated with them, and here's that when I click on it, here's all the details. KW exceeds target, target's 425, happened 22 times, cost me $3,900 in the month of March, total 142 hours, and here's where it was detected. All at a glance, all making that information useful to people who could do something about it, right? And this is an example of a bubble chart view. It's another way to look at the same exact results. The actual results underneath, the analytic finding, it's the same table of information, but now it's showing it for a different user in a different way that has meaning to them. Okay. So this is all wonderful, right? So how do we turn the data finally into money? So far, the only thing I've shown you is that I can turn the data into colors on a screen. Okay. Which is pretty cool, but isn't saving us any money. So what's the last mile? Let's get it back into those issues, okay? If you're going to get financial value, the organization has to be prepared to respond to the analytic findings. People ask us all the time, you know, how much will analytics save? And it's an extremely difficult question to answer because analytics is detecting the issues you have in your building. And before I apply the analytics, I don't know what's wrong with your building, right? So it's information to help guide us, set our priorities, determine where we should spend money. But I don't know. Now I have lots of anecdotal examples on retail and high rises and generally what it's going to save you, but can't tell you ahead of time. This is how you find out. And I can't stress this enough because as we started doing this 5 years ago, it was one of our surprises that it's not necessarily the biggest challenge to find all the issues. I could run in your building, I like to say, what if I'm a clairvoyant, right? And I can walk into the building and I could tell you 100 problems. Can you fix them? And we'd all like to think, well, of course, but that is not the answer to the question. The answer is, I'm not sure. How quickly could you fix them? What if some of them require capital spend and your budget's already committed or spent? What if they exceed your planned budget? This is one of the most interesting things we saw. A number of organizations who committed to these guaranteed maintenance programs that do have a limit to what they will address. They save companies money because they give them like an insurance policy on their maintenance, but they won't necessarily go into all of these findings. And you know what? If you've already got that approved by management, it's a little difficult to walk in and go, hey, by the way, I need to increase the maintenance budget that we all signed off on 8 months ago. It's a reality, right? That's how businesses operate. Just because you find this stuff doesn't mean they're going to get fixed immediately. But then I said, but what if you had a 1-month payback, when you propose all these energy conservation projects and equipment and chillers and LED, right? If you can get down to a 2-year payback, it's good. 1-year payback's amazing. What if it was a 1-month payback? Or like that airflow sensor, it was a 15-minute payback. Isn't that good enough for the financial people? And the result is, depending on how they budget it, they may want to do it, but that doesn't mean the money's available. So I emphasize this because it is so important to getting value out of analytics. It may sound simple, but it's actually the biggest challenge for most organizations. Okay? So what are the other challenges? So let's talk about if you're considering getting involved with analytics. The first thing you have to ask yourself, and kind of bring ourselves back to some of the initial comments, okay, now that we've seen it, what data do you have easily accessible? Okay, where is it? How will you connect? Will you need to add devices? Maybe you need to add a gateway. Maybe you need to add meters, sub-meters. I have no metering in my building. I got a great story for you. But, then this thing about how well is the data documented, right? That gets back to the whole tagging thing. Like you show me something and it's got a name and a value, but I don't know what it is. And if it's, even if I figure out it's this room, now I got to know, well, what air handler unit serves this room? What chill water loop is, you know, I mean, before I can understand these problems. So that is the data described well, and we've all seen, you know, just hopefully systems that do have good descriptors and as-builts, and a lot that don't. And that's that one right there is one of the biggest challenges, because if you don't know what the data is, it's kind of hard to provide analytics on it. Right? This is one of the other ones. You know, analytics is not one thing. You might even say it's not a thing, right? It's a tool. So the scope of your project is really important. For example, you could start and say, hey, step one, I'm going to do analytics on my meter data that's already stored in Excel. No networks, no security, no nothing, thumb drive, 3 years of meter data, interval meter data. There's a lot of really useful things you can pull out of that. Okay? So the scope of your project will decide, well, what rules do we want to get involved with? If all I'm doing is meters, I'm probably not going to get into any of my chiller plant rules, right? What reports, who's the audience, what presentations do we want available? All these things need to be considered when you're going to do a project, because the goal is to make sure the project's successful, right? So these are really them. It's a simple list, but it's not simple to answer all of these questions. You know, this one is a huge thing here. How will you connect? And that could fill an entire page, because, well, I'm going to connect over a network here and into that system. And have you talked to the IT security department about doing that? Which might be the, you know, that might stop your project, right? Or stop it for months and months at a time. Okay. So how do you get started with analytics? Well, the first thing we say is there is no need, and we recommend don't try to get started big, right? The goal is not to do a science, you know, I like to say, it's not to do a science project to prove how smart we are. The goal of analytics is one thing: make money. So what you want to do is get the most easily accessible data, be the least cost to get, right? That you can derive value from quickly. And if that means starting with just 2 pieces of data, then do it. We have a really interesting case study. I thought it was really fascinating because I was involved in, you know, presenting to the customer and selling it. And I think we're doing all okay on times here, so I'll tell you my little example. Okay. Did a presentation. Customer says, "This is wonderful, John. We want to get going." And of course, I'm excited. It was early stages of our company. Oh, great! We're going to have a sale. And then he dropped it on. I can give you 2 pieces of data. I have 65 buildings, but I can only give you 2 pieces of data. And I'm like, you know, I thought I was going to get. He says, "We have interval meter data. We paid for it like 3 years ago to do the meters, and every night it's put in a file on a server that I download." And he goes, "You know, every once in a while I look at it." Yeah, good. You know, you look at 65 buildings worth of interval meter data. And he looks at it to help justify that I paid for it, you know. And he goes, "The other piece of data I have is a spreadsheet where we record all of the lease occupancy times we're committed to." That's all he's got. Okay? Really interesting. Well, CSV interval meter data actually happen because it's available. It's pretty easy to get into a system. Okay? Pretty uniform. And the other one was easily brought in too. And what could you do with interval meter data and schedules? You can identify buildings that were running 24 hours a day, because you can see the signature in the KW pattern that, hey, this thing is not shutting off. Buildings that were running really late or really early, like, hey, isn't the lease rate 7 p.m.? What are you running till midnight for? And the classic, the 24-hour, it's always running. You know, call the manager down in, you know, the city and say, hey, we think maybe your building's running 24 hours a day down there. Oh, yeah, you know how we, you know, Class A office building, we take care of our tenants. We had some tenants moving in, you know, a bunch of lawyers moving in. We turned on everything. No problem, Jerry. I like you taking care of our customers. It's no problem. Hey, when was that, Jerry? Well, let me think now. I don't know, summer 2014? It happens. Yeah, that's an actual case. And the other thing he found was weird times for demand peaks that were actually costing him money in his portfolio that he was able to go and address because he could see them. Like, why are we having these peaks like this? And one of the great cases is he found one that kept happening on a monthly basis. And he was getting slammed. It was in southeastern United States where the demand charges can equal the consumption charges, okay? And 11-month ratchet. He finally tracked it down. One of his operators was diligently test starting the generators, okay? And then shutting them down and setting a demand spike. He was actually able to go argue with the utility company to let him out of the ratchet when he showed what it was, that it really wasn't going to be a consistent load. Because all he had to do was hit it for one 15-minute period in a year, and he was stuck with it for a year. And he had the evidence to go and argue it. He was a pretty persuasive guy, too, but he had the evidence, okay? You know, that does the power of analytics. So anyways, you want to get the most value you can from the most easily accessible data. Get results quickly, okay? So the question is, what data do you have? And the quickly thing I want to emphasize, you know, to get back to a human factor. We're all human beings. I know one of the things I hate is making an investment in something I'll never see for like 6 or 9 months. Don't we hate, oh yeah, we get that project approved. And time goes on before there's ever any proof that it was any good, and the champion gets promoted or fired or whatever, and the new people don't even know what get results in 4 weeks, you know? Show how powerful this can be, and then the organization feels better about continuing down the road and can see how this can make money for them. Okay? There's lots of providers out in the marketplace, so you know, there's many people that you can talk to about analytics, and they follow different business models or deployment models. There's a whole school of analytics as a service, which is they'll come in and do it for you as a consulting-based model. They'll worry about the data onboarding. They'll worry about setting up the rules. They have expertise. You know, maybe engineering firms have expertise in different system designs, and then they will not only get the results, but they sit with you in a consultative. Here are the top 5 problems we found for you this week or this month or this day, whatever's appropriate. So that consultative model fits for some customers. You don't have an internal staff. You don't want to take on the setup. But then you have the other type of customers. They want it. They want to own it. They want it in-house. They want their internal energy and facilities people to be using it daily. So that is an option available out there in the marketplace. So you need to consider that too, about which is best for your organization, your resources, your talent, you know, the talent you have in your organization. No matter what your answer is, there's a way you can move into analytics. Okay? So, you know, what are value propositions and why should facility managers consider this stuff, right? It's simply like having an ever-present expert just watching everything, you know. If you could have a team of engineers watching every sensor every minute of the day, what would they see? A lot of really wild stuff. You can't have them. Well, with a software tool, you can, right? It gives you smart, intelligent exception reporting, and it gives you this continuous monitoring, commissioning. The idea of cross-referencing and this correlation gives you the answer to why these things are happening and prevents, you know, kind of chasing down these cascading alarms. Monitoring, verification, and validation is very important. You know, you're validating against benchmarks or internal goals, and then supporting M&V requirements. M&V can be done without these tools, but it can be done a heck of a lot more efficiently, consistently, and be more of a tool for the whole organization to act on the results with these types of tools. You know, the other thing it does is really interesting how it can affect the budgeting process. If you know more about what your issues are, you're going to be able to propose, possibly get more money because you can demonstrate how it's going to have return. It becomes a key tool in the capital budgeting process and in the you know, maintenance and repair operation budgeting and priority selection, because you know, you're not operating blind. You know what's going on. And you know, one of the other points is, you know, driving efficiency and cost reduction is proven. There are literally tens of thousands of examples of this, and you easily and regularly see savings in the 5 to 30% range with return on investment in less than a year. That's great. The challenge is being able to prove that up front. You really can't. You have to have trust, credibility, start with a small pilot, prove results with a minimal investment, and then the path becomes very clear. But again, we need to be prepared to act on the findings. Without that, that is the one time there is one time I can guarantee the savings from analytics. If you don't fix anything, you will save exactly 0. All right. So, anyways, we've got time for questions. Be happy to take any questions that people have.